Hi, my name is Ravi. Welcome to my channel Payment Talks. Welcome back. This week we were supposed to start with the Paint001 fields, but Paint001 have more than 3000 fields. How can we cover those? But don't worry. If you actually analyze not only Paint01, almost all ISO messages like PAX8, PAX9 and other messages have comparable number of fields like their counterparts in MT, which is in few tens. Yes, that's true. But to create that mental map, you need to understand two fundamental concepts. First is the philosophy of ISO, which we are covering as part of video series. We are yet to unfold a few more fundamentals there still, but we will cover when the time comes to make you understand ISO like a pro. The second part is the MT basics. Without MT basics, it becomes hard to understand ISO message and then to retain that knowledge when it is needed. In this video, we will cover the very basics of the MT message and how to read any MT message. Then we will understand how ISO 20022 evolved from this MT standard. Firstly, let's understand why MT now when world is moving to ISO. ISO 20022 is now the strategic messaging standard endorsed by Swift. However, MT messages still flow daily. Many corridors remain MT based. Legacy systems continue to store and display MT data. Payments today are hybrid, not ISO exclusive. Modern architectures rely heavily on MT to ISO translators, ISO to MT downgrade paths, enrichment and truncation rules. You cannot design or validate these mappings unless you understand MT field lengths, optional components, slash semantics, line repetition rules. MT field formats define what data existed in the first place. Many ISO 20022 concepts exist because MT could not express them cleanly. Free text to structured elements, multi-line names to explicit party roles, slashes to XML tags. MT formats are the problem statement. ISO 20022 is the solution. In 2026, many people try to learn ISO 20022 before understanding MT deeply. MT expertise signals end-to-end payment understanding, ability to work across generations of systems, strong debugging and analysis skills. Now what is a MT message? An MT message is a structured text-based financial message defined by Swift. Each MT message serves a specific business purpose, example customer credit transfer, interbank transfer, follows a predefined structure and must comply with strict formatting rules. Unlike XML based standards, MT messages rely on positional parsing and character level validation. We have already seen the high level MT message structure. An MT message is divided into 5 logical blocks, each enclosed in curly braces. Key points are curly braces are block delimiters. Blocks are identified by block numbers 1, 2, 3, 4 and 5. The end of block 4 is explicitly marked by this symbol hyphen and a closed curly brace. A missing or misplaced block delimiter invalidates the entire message. Then what about the information inside these blocks? Firstly, block 1 and 2 have standard format where they are just mentioned without any delimiter. They are fixed length and mandatory. How are elements in especially block 3 and 5 represented? These are header and trailer elements. They are also represented by curly braces. Though they seem like normal tags, they are not. They are represented as shown with curly open curly brace, field number, semicolon, value and then the closed curly brace. This format is applicable only in these blocks of 3 and 5. In ISO message, some of these information are moved to specific XML tags like tag 121 of block 3 to UETR tag. MT field formats apply primarily to block 4 text block. Please refer to the overview of empty blocks article given in the description for more information on fields in the blocks. Empty messages are generally sent across empty fin files. These files contain multiple empty messages in a single file. Each message is separated by a special symbol, that is dollar symbol. Every dollar symbol indicates that a new empty message containing 5 blocks is added to the empty fin file. Now we will understand what is a tag. A tag in block 4 is a field identifier that tells the parser what business information follows and how it must be interpreted. Empty messages are not self-describing like XML. There are no element names or schemas at runtime. Tags solve this by identifying business meaning, enforcing field format rules, allowing deterministic parsing, enabling message type specific validation. Without tags, empty messages would be ambiguous free text. Format of tag is as shown here: colon, tag number, and colon. Tag starts and ends with colon, and line break ends the field value. Block 4 tags consists of 2 or 3 digits, sometimes followed by a letter option. Numeric part identifies the business field. Same number means same business role. Example, like 50 is debtor, 59 is creditor, 57 is creditor agent, and so on. Letter option tells different data representation and different format rules, like 57A or 57B or 57D. All talk about creditor agent only, but the letters A, B, and D tell which information of creditor agent can be expected. We shall look into these letter options in detail in a while. Let us understand tag rules first. Tags always start on a new line. Only one tag per line start. Tags are case sensitive and always uppercase. Fields must appear in the prescribed sequence. Now we understand what are tags. Nothing but empty fields. Let us now understand how these empty fields are formatted inside the empty message in block 4. Swift defines field formats using symbolic notation, not examples. This notation precisely defines allowed character types, length constraints, repetition rules. The core format symbols are as shown. Empty messages do not have a single global uppercase rule. Character case depends on the format symbol used. Let us see some of the most commonly used ones. First are A, C, H. These character sets allow only uppercase letters. Lowercase is not allowed. Mostly used for currency codes, qualifiers, and identifiers. Next is X, Swift character set. It includes lowercase letters, along with uppercase letters, digits, and also allowed basic punctuation. Most name and address fields use X character set. When you see actual Swift empty messages, they will be mostly in capital letters. Someone working in operations can see that the old systems always show the empty messages in capital letters, even the name and address fields. This uppercase only behavior, which is seen in practice, is an implementation choice, not a Swift rule. Then comes decimals and numeric notation. D represents decimals. In this, the decimal separator is comma and not full stop like normal numbers. This decimal separator is mandatory to be present, and it is part of the length count. Thousand separator is not allowed. N represents numbers. In this, neither decimal separator nor thousand separator is allowed. Only numbers and nothing else. Let's look at some examples. First notation is 6n. This means 6 numbers allowed. First example is valid as it contains all numbers. The second one is not valid as it contains other than numbers. Third example is not valid as it contains decimal separator or even as thousand separator. Nothing is allowed. Second notation is 6D. This means 6 digits allowed including decimal separator. First example is not valid as with decimal separator the length is 7. Second example is not valid as full stop is not decimal separator. Third example is valid. Fourth example is also valid. It has mandatory decimal separator and within limits. Fifth example is not valid as mandatory decimal separator is missing. Third notation is 10D. This means 10 digits allowed including decimal separator. First example is valid. Second example is not valid as it has full stop and comma as separator. Third example is it contains 2 decimal separators, so system cannot parse. 1000 separator is not allowed. Fourth example is valid as there is one mandatory decimal separator and it is within limits. The next concept is field length indicators. Usually the core format symbol is preceded by a number, which means that particular field can contain up to that number times that core format character set. Few notations are 3n, meaning up to 3 times the core format n, which is numeric, can occur. 35x, meaning up to 35 times the core format x character set can occur. Now comes exclamation mark. 6 exclamation mark n, which means exactly 6 numeric values. The exclamation mark in empty format means mandatory field length. If exclamation is not there, then it is maximum value. For example, for 4a format without exclamation mark, ABCD is valid. Less than 4 characters, ABC is also valid. More than 4 characters, ABCDE is not valid. For 4 exclamation mark A format, only ABCD, exactly 4 characters, is valid. Either less than 4 characters ABC or more than 4 characters ABCDE is not valid. The exclamation mark enforces exact length, and this distinction is critical for positional parsing. The next concept is repeating lines. Many empty fields allow multiple lines represented by star notation. Notation format 4 into 35x, meaning up to 4 lines with each line having a maximum of 35 characters of the x character set. Few rules are that lines must be sequential with no empty lines in between and no skipping line numbers applicable for formats like F letter option. We will see this F letter option in a while. This 4 into 35 notation is commonly used for name and address. But this star notation is also used for other fields like remittance information tag 70, regulatory reporting tag 77, sender to receiver information tag 72, etc. The next concept is composite field formats. Some fields concatenate multiple business elements into a single value. For example, field 32A, format of this field is as shown. If you break down this format, there are 3 fields inside it. First, value date with YYMMDD format. Second, currency. And third, amount information. Sample field looks like this. Here, no separators are used and interpretation lies entirely on format rules. In ISO, each of this field is having a dedicated space inside XML structure, like value date separate field, currency and amount separate fields with proper naming. So one field in empty now split into 3 fields in ISO. Next concept is field level optional data denoted by square brackets. For example, let's look at format option A of an agent. You can see the format here. The option itself says it is 2-line field with line 1 being party identifier and line 2 being identifier code with respective formats again. If you closely observe, firstly, this is a composite field format. Let's analyze line 1. It has two parts. Both the parts are inside square brackets, which means both the parts are field level optional. If you see second line, it contains a format in which last part is field level optional, but then the field itself is mandatory with 4 plus 2 plus 2 characters mandatory and last 3 characters as optional. In the first line, the first optional field takes only either C or D letters indicating the credit or debit when the account number is mentioned in the second optional field. But as per field format guidelines, any capital letter is allowed. There are some rules around it, but I will not get into those for now. Let us look some examples. I would recommend everyone to pause and think about each sample to understand the concept. Okay, sample 1. Is this correct? It is not. Reason? If you see the format, the second line is okay, but the first line, which is optional in nature, but if it is present, then it should start with slash. Here it is missing. Now sample 2. Is this correct? Yes, it is. As the first line starts with slash, which indicates that it is the optional information which is present. This is the account number, and mandatory second line is present, which is the BIC. Now sample 3. Is this correct? It is not. Reason? If you see the first line format, the first optional element, if it is present, it has to be only one character. Till here it is good, but that character is of the nature small a character set, which only allows capital letters. Here C is small, which means parse error. By the way, this is applicable to the second line also. If you see the second line, the format is given in a complicated manner, but it is actually BIC field. As we all know, BIC field is comprised of first 4 letters of bank, then 2 letters country code, and then 2 characters location, and then final 3 characters which is branch. Exactly same is represented here in the empty field format as specification. It consists of character set A and C, both of which only takes capital letters. So BIC should always be represented by capital letters in empty messages. Let's move on to sample 4. Is this correct? It is not. Reason? The first optional field has slash and character. Here slash is missing, so it cannot be parsed. Now sample 5. Is this correct? Yes, it is. Reason? It perfectly fits the format with first line both optional fields present and second line has at least mandatory characters without optional branch information. Now sample 6. Is this correct? Yes, it is. Reason? In first line it does not have first optional info but has second optional info in correct format. Now sample 7. Is this correct? Yes, it is. Reason? The first line has both optional fields. Here they are absent, with the second mandatory line information present in the right format. Now sample 8. Is this correct? Yes, it is. Reason? All the field level optional fields are absent, but as per the format, bare minimum mandatory information with right format is present. Now sample 9. Is this correct? Now this is a tricky part. Actually, it is not correct. Reason? The only line that is present is starting with slash. Though the information inside is actually a BIC, but the system reads this as party identifier. Now this is not the actual issue. The actual issue is here. The mandatory second line, which does not start with a slash, is missing. That's why this will fail in the parse error. Now sample 10. Is this correct? Yes, it is. Though it seems like BIC is present in both places, the system reads like first line which starts with slash is treated as party identifier and the second line without slash is treated as identifier code. Now here is the thing. We might intuitively think the information which we see on empty messages as correct or wrong based on the data. But the system strictly follows the field formats. Like in sample 9, we intuitively think I gave BIC info but Y is parsing failed. Similarly, I gave BIC twice and Y is parsing still working. In ISO, this confusion is not there. Every element has a specific placeholder inside XML structure. Intuitively, we can clearly understand that if BIC information is placed in account number field, then it is wrong. In empty messages, optionality is positional, not arbitrary. Hope with these samples, we understand the field level optionality and how to identify if any errors. You can extend this knowledge to other empty fields. The next concept is separators. There are two types of separators. One is single slash and another is double slash. Single slash is used to prefix account numbers, separate sub-elements. Whereas double slash is used to separate coded data from narrative text. Let us see some examples. First, in the agent sections. We already saw the single slash is used as a prefix to account numbers. In the same agent sections, double slash is also used, but for specific purpose of indicating the local codes of banks. Here, double slash FW indicates that the value followed by FW is the Fedwire ABA code. Similarly, for many national local IDs like sort code, IFSC code, we have codes which need to be used with double slash. Second main usage is in the tag 72. Here, single slash is used to indicate the code. So each line starts with a single slash followed by code and followed by single slash again. Then the value occurs. If there is another code, then it will be starting in the next line. If the value of the code is more than the maximum line length of 35, it will continue in the next line with double slash. Just remember rule of thumb. Single slash is element separator and double slash is semantic break. Next, we will cover one of the important topic of empty message, that is letter options of empty message. Many empty fields support letter options indicated by a letter after the field number. Examples 50A, 50F, 50K, which are letter options of the party field. Similarly, 57A, 57B, 57D, which are letter options of a agent field. What letter options mean? The business role represented by the field number remains the same, and the letter option will determine the representation and format of the fields. Common patterns are option A, which represents structured code-based BIC. Option F represents the structured name and address with components. Option K represents unstructured name and address free text. Option D represents same name and address free text for an agent. Key rules are only one letter option per field per message is allowed. Letter options are mutually exclusive, which means only one can be used any point of time with its own information. Each option has its own format definition. Letter options are an early mechanism to balance structure versus flexibility. Now we understand the empty message formats have complicated way of adjusting information using different format styles. Firstly, it has limited space in each format type. That is, for example, you have only 4 times 35 characters for entire name and address. Then it has another limitation, that when I send name and address, I cannot send BIC and vice versa. Here comes ISO. ISO 20022 removed the letter options entirely. Instead of letter options, ISO defines single party and agent structure. which has all the elements that can be possibly attribute to the business role. It keeps business role fixed at the top, like for example creditor agent, and inside this tag it created all the possible XML structures to capture the data. So it is very important to understand empty to appreciate the ISO 20022. Now we clearly understand the field level formats of empty message. But there is one more important point to note. That is mandatory, optional and repeating fields at the message level. Now what is this? At message level, some fields are mandatory, some are optional and some are repeatable. A field may perfectly formatted and still invalid if it appears when not allowed. It appears too many times, it appears out of sequence. For example, in MT103, field 36 is optional at a field level. But if the field 33B is present and the currency code is different from the currency code in the field 32A, field 36 must be present, that is, it becomes mandatory. Once it becomes mandatory, then again the field level format has to be maintained. Field 36 cannot appear without field 33B. Similarly, field 71F, sender charges. It is optional at field level, but it may be present, and in certain cases it can also be repeated. The order of the fields in the whole message also should be maintained as per the spec. Now these are called message level validations. In Swift spec, these are called as network level validations. Empty formats have a validation philosophy. Empty field formats are designed for deterministic parsing, minimal ambiguity and high resilience in legacy systems. Even a single character violation can break parsing, cause rejection and lead to downstream misinterpretation. Final takeaway is that empty field formats are not absolute trivia. They are foundation on which modern payment messaging evolved. Understanding them gives you deeper system insight, stronger debugging skills, better ISO 20022 comprehension, and real world payments credibility. MT may no longer be the future, but it is still the grammar of today's payments reality. With this, we come to the end of this video. Until next time, keep smiling and keep learning. Thanks for watching this video. If you like this video, please like, subscribe and share for more such interesting topics on payments.